Hello, my name is Martin and I'm going to be your teacher for this course in Cloud, NFV and SDN. NFV is of course for Network Functions Virtualization and SDN for Software Defined Networking. Cloud is for, well, who knows? Let's get into that, shall we? My background is teaching telecommunications and mobile telecommunications specifically for the last 20 years. So I've been going through all the motions of, TCP/IP, switching, routing, those things through 2G, 3G, 4G, now a lot of 5G going on. Has been a lot of voice over LTE and SIP and IMS. And as of late, quite a lot of these things, cloud and virtualization, as all these different areas that I mentioned pretty much merge, and it's difficult to keep track of these things. So I hope during this time to give you an sort of bird's eye perspective of some of these things so that you can see how some of the pieces of the puzzle fit together, so to speak. So let's jump right into it, shall we? What is cloud? Well, we had three words, right? Cloud, NFV and SDN in the title of this course. Now they are different when it comes to the definition of what they mean. NFV is actually easiest because there are papers published by ETSI, the European Telecommunication Standards Institute, that say NFV on the front page. So you can some people call it a standard, and it's becoming more and more reasonable to call it a standard. In the beginning it was more of sort of recommendations, but now they're actually having rules in there. And so NFV is sort of pretty much clear. NFV is an ETSI product. SDN is software-defined networking, so we know what the letters mean anyway. It's not a standard. It has come from academia, from universities, the idea of software-defined networking. So it's not a standard, it's not a product that someone sells. And if you ask different companies and different persons, they will give you slightly different meaning of what SDN is. Still, there is sort of a consensus of what at least could fit into the SDN family. So we are coming back to that a few chapters into the course. Cloud is almost completely undefined. I mean, cloud, there's a lot of talk about cloud and cloud technology and running things in the cloud. But what is the cloud? Well, if you ask a gardener, he has his meaning of what a cloud is. But even if you ask engineers, they have very different meanings of what they think cloud really is. So, I mean, since we have it in the title, here's 1/3 of the title. I mean, it would be embarrassing if I didn't have anything to say about it. So we do have a suggestion for you, which works pretty well. Cloud is network access to shared resources. So there are two elements here, network access and shared resources, and they are equally important. If we have a network here, let's say an IP network, because that seems reasonable, and we have connected to this network resources, and the typical resources that we constantly talk about in cloud technology are compute, network, and storage. And these are very physical things. Compute is like real servers in racks, in data centers, and network are switches, routers, cable, fiber, and storage is hard drive clusters of different kinds. So these are the resources that we mentioned down there. But then we have to share them. So we need to have users over here. These cloud service users could be persons like it looks like here, but it could just as well be, different companies or different computer applications using these services. it makes it easier if we have people over here, because then maybe we can talk about storage. Let's say storage cloud services like Dropbox or Google Drive. That's a cloud storage service. So we have users over here. They access the hard drives using this network, and they don't know, they meaning these users over here, they don't know exactly in which hard drive their pictures or their files are stored. It's just somewhere in the Google Cloud or in the Dropbox Cloud. And they never seem to run out of space either. They can just swipe their credit card and get more storage space. That's part of the magic of cloud. So it's important that they share these resources, because if you start dedicating hard drives to these users, or dedicating network equipment, or dedicating CPUs or servers to these persons, suddenly it doesn't become that flexible. And flexibility and scalability are some of the most crucial elements of cloud technology. So we need network access to shared resources. There is an organization called the NIST, the National Institute of Standards and Technology. The nation here is the US. This is the US National Institute of Standards and Technology. And they came up with a definition of cloud a little while ago. Now, we are going to talk in this course about just general cloud technology. And then after a little while, we're going to move into what can be called telco cloud. And that's where some people say NFV fits best. We can leave that discussion for then, but general cloud has been around longer than the time during which telecommunication companies have been interested in cloud. So some of the general cloud definitions that they put forth and that are still being used don't fit as well for telco cloud as for general like datacom cloud. And this is also a distinction that we are going to come back to during the course and discuss and sort of flip over and look at from different angles. So what they said, NIST, is cloud computing is a model for enabling convenient on-demand network access. So that's partly where we got that from, network access to a shared pool of configurable computing resources. Okay, so network access to shared resources. And they say computing resources, for instance, network service, storage, application services. So they sort of expand there from the just compute, network, storage. But I reiterate to you that these three major Lego bricks, compute, network, storage, it's the three resources that are being used in the cloud business over and over again. Okay, so we discussed that. Then they add this, that they are supposed to be rapidly provisioned and released. What does that mean? Hope you have your coffee over there at your place. This is good coffee. Rapidly provisioned and released is not the way it has historically been with deploying things in data centers. If you have some kind of service or a server and suddenly you, maybe because of increasing demand, you need more power, you need more capacity, you need more of something, so you need to buy another one of those servers. Maybe you had 4 and then suddenly you realize, hang on, my business is going really well, I need number 5. I mean, how long would it take for you from the moment at which you realize you need server number 5 to the point in time where some server number 5 is installed in the data center, configured, up and running, doing its job? If you look historically back in time and ask people how long time does that take, this is something that I have done, by the way. I mean, I travel a lot teaching these things, so I ask people. It's difficult to do right now when I'm recorded to you, but I do meet people in real classrooms as well, and I ask them, so how long time does that take? And it usually varies between a couple of months to up to 1-2 years, depending on how easy it it is to sort of get decisions through in the companies where they work. And that's not very rapid. We want to be able to essentially start that server up at the moment when our demand crosses a particular threshold. So if we include the possibility for virtualization and the possibility to have unused resources just standing ready, unused generic resources just standing ready, then this number, the number that went from a number of months to a number of years, can come down to tens of seconds, maybe in some instances even fractions of seconds. And I think you'd agree that that is rapid compared to months and years. Also, playing into this is their next distinction here, the minimal management part. Because if we want this to happen, as I said, at the moment the demand crosses a particular threshold, we want server number 5 to just start up and start doing its job. We don't want to have a person employed just watching that graph and sort of measuring with a stick. When does it cross the threshold? Now I will press start on server number 5. No, of course not. We want this to be automatic. Automatic is similar to minimal management. So when we move from doing everything manually to sort of trying to make things scale out and in, following the tide of how much data you need, how much CPU you need, how much network you need, how much storage you need. We want this sort of following of the tides to be automatic as far as possible. So the NIST came up with a number of essential characteristics, 5 of them in fact. Also 3 service models, which I think you've heard of, and 4 deployment models that you may have heard of. So I'm going to go through these and tell you about them. First, the 5 essential characteristics. These are the top 5 criteria, what defines cloud and cloud services. The first one is arguably the one that is least applicable to the telco world, since we are moving into the telco world and some of you may be working in the telco business. I'm addressing that already now. But these criteria were defined for just any general cloud service, like Hotmail, or use any web service essentially is a cloud service because you are using it over the network and you are sharing it with other users. So they said a cloud service, you should be able to use any form of thick or thin client because we want ubiquitous network access. Ubiquitous is a difficult word to spell and sometimes know what it means, but it means always present. So in our world, electricity is ubiquitous and internet is very close to ubiquitous. We have it everywhere in our computers and phones and cars and TVs. That's not true all over the world, of course. So in order to fulfill the requirement of ubiquity here, the suggestion is, well, if you use web-based services, well, we have web browsers everywhere. So if your service is web-based, it kind of becomes ubiquitous. So that's one way to solve that. You want to reach your webmail from wherever you are in the world, for instance. If you have cloud services in a telco environment, you may not want everyone in the world to be able to reach your packet gateway or your user databases. It's more sort of rigorously controlled connections in there. So we're getting back to that in a little while. Moving on, they say measuring the service, making sure that we know how much of these resources you use. Remember the resources: compute, network, storage. Why? Well, for one, we need to measure in order to be able to get what you want. Maybe you're using so much that we need to sort of scale things up. Inside that, as a cloud provider, I may need to buy new equipment here, servers or routers, switches, hard drives. Also, if you're paying for these services, let's say you're paying for network storage, it's good to know as a customer out here that the cloud service provider knows how much you're using. So if you get a bill at the end of the month that just says, you have bought cloud, $1,000 please. You may start to wonder, okay, so it came to exactly $1,000. Did I use storage space that matched exactly $1,000, as opposed to getting a bill that says, first day of the month you used this amount of gigabytes or terabytes, that came to $27, and the second day of the month you use this amount of storage space, and so on. It lends a credibility to the cloud service provider, actually saying that we know what you're using and we're charging you for exactly what it is you're using. This is a real pay-as-you-go service, because that's something that we're after. Third essential characteristic, resource pooling. And this is the whole sharing that was in my first definition, the network access to shared resources. So if we have resources in here, we want to be able to share these resources among the customers, A, B, C, whether those are companies or persons or applications or whatever those are. Excellent. Fourth essential cloud characteristic, on-demand self-service, they say. And this is largely another way of saying the automation that I mentioned a few minutes ago, where it said minimal management. Now, minimal management, there are two sides to this, because we have sort of two parties involved. We have the cloud service provider in here, and we have the cloud service user out there. When we say minimal management, that reflects the cloud service provider, not necessarily the customer. In fact, minimizing the management on the cloud service provider side could make the amount of work that you have to do on the customer side larger. If you, I'm sure that in today's world, you have been in this situation where you want to contact a company because you have a complaint, or you're searching for information or something, and you're looking for a phone number, someone to call, and you can't find it anywhere. You can't call this company. Instead, you find email addresses, or even more, you have FAQs, frequently asked questions, you have automatic, interactive voice responses where you call somewhere, you push buttons, and you automatically can access the services of this company. It would be easier for you as a customer if there were a person in here just picking up the phone and helping you with what it is you want. Instead, we employ all these different automation schemes in here, which makes it more scalable for the cloud service provider. No humans involved. See, we have two non-humans here. Instead, you get to do more work as a customer, because you need to go through all these different menus, pushing buttons, maybe saying things to the IVR in the phone, maybe emailing, automatic services. So no human interaction required, minimal management from the cloud service provider side. And finally, rapid elasticity. Do you see the rubber band here between these two fingers? So they can go sort of like this, which means that I pay for what I use, and I feel that I have the option to use as much as I want. Me as a user, I perceive an infinite cloud. If I need more storage space, I just enter the details on my credit card and say, I want 10 more terabytes of storage space, Mr. Dropbox. And they say, okay, immediately. It would be very surprising if they said, we are out of storage space right now, but we're going to run off to Radio Shack, buy a new hard drive, and we'll get back to you when we have that installed. Instead, it's infinite to you as a user. This gives me a good moment to point out something, a sort of an erroneous position that some cloud service providers have. Because I've met a lot of customers, but I've met even more cloud service providers, because they are typically our customers, you know, conventional operators in the telco world. And sometimes people in this cloud say things like, the cloud will take care of that. Because they've heard people say that. The cloud will take care of that. Do we need more storage space? The cloud will take care of that. Are we running out of bandwidth? The cloud will take care of that. And these are things that you can say if you're on the outside, because the cloud service is supposed to present itself as an infinite cloud. But infinite is, of course, not something that can be real. You can't physically have infinite resources in here. This rubber band here, it looks like a rubber band. It looks like it's infinite seen from the outside. On the inside, you still need to have real data centers with servers in racks, and you need to have them connected with cables to switches and routers, and you need to have those connected to, you know, network attached storage, hard drive clusters where you store things. And you need to be alert so that if the total amount of storage, let's say, for instance, just as an example, that your customers are using, if it's coming close to some kind of threshold you've set, maybe 80%, maybe 90%, at that point, you do need to buy more storage space. You do need to run away and buy more hard drives. But you need to be clever enough to be able to do that before your customers ask for it, so that they still perceive an infinite cloud. So on the outside, it's magic. On the inside is really, really, really not magic. That's also something that I met people who need to understand, people who work inside the green cloud here. All right, moving on. These were the 5 essential cloud characteristics from the NIST. They also defined a number of service models, and the service models I mentioned, I think you've seen them, and they are things that end with as a service. You've probably seen more service models than the ones that NIST gave us, because the trend of saying something as a service has really sort of almost gone exponential. But they started off with these things. They look at the whole stack of stuff, all the way from the hardware of your service, where network storage service, the real things in your data centers, all the way up through virtualization operating system, all the way up to the application and the actual data that you are using in your applications. And then they divided it. If I put this part in the cloud as something I can buy, leaving the rest for the customer to add, we call this infrastructure as a service. This is infrastructure down here. It's not operating system as a service or application as a service or data as a service. It's the lower layers as a service. So this is infrastructure as a service. If I move on a little bit and add a couple of these layers to the thing that I'm buying from the cloud, the thing that is in the cloud even before I swipe my credit card. So I add maybe an operating system, maybe a database, maybe a web server. So not the actual web pages, just the web server software. That usually goes under the name of platform as a service. So it is given me a special platform. It's not as generic as infrastructure as a service, because it has all of these things already installed. But then again, most people don't want the hassle of installing all these things. So running platform as a service is a good idea. And if you want even less hassle, then you buy the whole stack, and then it's software as a service, SaaS. And that can be said of pretty much all web services. If you go into a web page today and you use it in a way that you feel like a service, well, have you paid any attention to the physical service that this is running on, or the hard drives it's using, or the routers and switches that the packets travel in? No, you probably haven't. If you use that service, have you paid any attention to the operating system running? Probably not. Have you paid any attention to the actual application running, providing you with the service, giving you the graphical user interface on the web page? Have you paid any attention to patching this application for the latest security threats? No, you haven't, and you shouldn't, because this is software as a service. This is just swipe your credit card and start using it. So you could say essentially that this is something, infrastructure as a service is something that you use when you want to build something from the bottom. You have really your own idea how you want to build it. Platform as a service is something on top of which you deploy sort of a package, but the basis, the platform, is already there, whereas software as a service is just something you buy. This term as a service, or this sort of addendum as a service, is, I was trying to find the word of suffix, that's it, right? Prefix and suffix, something that comes at the end of a word. That's something that has been almost hijacked to be used for lots of other things. So there is an almost infinite amount of things as a service. We have metal as a service, if you are sort of even lower down in the architecture here. There is firewall as a service, load balancer as a service. All of these are things that you recognize from the telco world, right? But it's also been adopted by other companies. So you have accounting as a service. You know, I offer a service over the web. That's something as a service, isn't it? So accounting as a service. Car services like Uber and others are sometimes describing themselves as car as a service. You know, we run everything. You don't need to care about anything. You just buy and use our service, which of course was the case previously as well. We just didn't call it car as a service. So it's a little bit trendy to do that. A few simple as a service examples just to finish that off. Software as a service could be webmail, for instance. If I log into Gmail or Hotmail or something else, I really just pay, or even if it's free, I pay by watching ads. And I don't patch anything for security threats. I just use the service. Platform could be web hosting. I have my own web pages. That doesn't come from the service, but the database and the operating system and the web server software is already running there in the software. This is exactly what you buy when you go to a web hosting company and say, can I please put my web pages on your service? They give you all of those things and you just upload your web pages. Infrastructure as a service, even lower down, maybe you want to construct something, maybe you want to construct a firewall, then that could be construed as infrastructure as a service. Maybe this looks odd, by the way. It's not that odd to have a firewall that's not where you are. Some people look at a picture like this and feel that this is insecure, but I want to have the firewall very close to me. But then again, if you ask that person, do you trust VPN? Virtual private network, an encrypted connection from point A to point B. Most of these people do trust VPN. Sorry. Maybe you have VPN connections between branch offices at work, or maybe you use VPN from home to work and you trust that. So if you trust VPN, then this connection is secure, and then instead of running your firewall here, leaving you to have to handle it, and you are maybe not a firewall expert, instead you can just buy that service from somewhere. Some company that is very good at running firewalls, keeping them up to date with the latest threats and doing all the right stuff that you need to do to keep a firewall happy, then you can buy that, and that could then be called firewall as a service, that particular service. Finally, cloud deployment models. I said that the NIST gave us 4 of these, which was true, but I'm cheating a little bit because 3 of the ones that I'm going to show you were the original ones. And the third one is actually a new one, but then again, another one has sort of gone out of fashion. So it's still 4. I'll tell you all about it. First, private cloud. If you are a company that have amassed so much IT equipment, servers and routers and hard drives, that you're not using it efficiently, it makes sense to have this as a cloud service. You can do that inside your own company. All of this is disconnected from everything else in the world, at least when it comes to these services. We have different branch offices in this company, and we have an IT department running your internal private cloud. So we have network access, like this, to the shared resources in here. We get all the benefits of scalability and flexibility. We don't share with others, like on the internet, but we share internally. So this may not be something that 1 or 2 man company is doing, but in a 20,000 man company, this is not unreasonable. So lots of big companies have their own private clouds. For natural reasons, if I give examples, it's more difficult to give examples of how private clouds work because they are, well, private. Not all companies want to brag about what they do internally. Some companies do, but others don't. So it's easier to get a grasp on this. Public cloud. This is everything on the internet. So the services that I've talked about so far, like Dropbox or Gmail or web hosting companies, Amazon Web Services, is public cloud service. So you're out here, you're going through your internet service provider, and somewhere on the internet is a cloud service provider hosting these resources that you share with others out here on the internet. Okay. So if you want both of these, that's okay. You want private, but you also want public. Then that is called hybrid, a mix of private and public. So this company up here, you may note, is the exact same picture as this company here. And it says company A and company A. So it's the same company. So they have an internal network, an internal cloud infrastructure, but they also buy services from the public cloud. Why, you say? Why do they want that? Why not stick to one solution? This looks like complexity, and it is, but there are reasons. One reason could be that you would want to put everything in the public cloud, but for security and policy reasons, you're just not allowed to. Maybe it's even like the regulatory authorities in your country. Maybe it's the law that you're not allowed. Maybe it's like the legal system company or the police or the military. So you're not allowed to put it in a public cloud. But then again, most of the things is not maybe that classified. So let's put all the non-classified stuff out there on the public cloud and put all the secret stuff in here in your private cloud. That could be one reason to have this hybrid. Another reason to have the hybrid could be that you want to run as much as you can in your private cloud, but let's say that the demand for those resources vary over time. Maybe the demands vary quite a lot over time. Maybe it's sort of trickling along on this level most of the month, and then towards the end of the month, every month it just shoots up like this for a couple of days and then goes back down again. how would you dimension your resources in here? Would you buy servers and hard drives and network resources that match sort of the general level throughout most of the month, or the average, or the peak? Well, if you don't cover for the peak, then you won't be able to handle the peak. The lower trickling level or even the average just doesn't cut it when you come to the peak. So what you can do is that you can have resources that are matched to your normal most of the month consumption of resources. And then when the demands start to rise, you buy extra resources from the public cloud. This is sometimes called cloud bursting, when you have most of your activity up here and then sometimes you burst out into the public cloud and buy resources there. I often go to, I'm Swedish, I live in Stockholm. I often go to one of the big theaters, Stockholm City Theater in the center of Stockholm. And they're very good shows. They have one bad habit, which is releasing tickets per season. So they have like advertisements in advance. They send me emails saying, next Monday morning at 6 a.m. we're going to release this autumn's tickets, which is not good because you can imagine what happens at that moment in time. Everyone who wants the best tickets log in, and it becomes very syrupy managing, navigating through this website. So it can take, tens of minutes to buy those tickets. And it's so predictable. They know this is going to happen. Maybe they have, it was a couple of months since I bought tickets last, so maybe they have upgraded to cloud bursting now. But if they haven't, this is a tip for you guys at that theater. Just at that particular moment when you are releasing those tickets, just buy a little bit of extra web service capacity so that all your customers are happy. So these three cloud deployment models were in the original suggestion from the NIST. There was a fourth one, which was called Community Cloud, which doesn't have a lot of good real-life examples, so that's why we haven't included in here. It's generally, if these here were not the same company, but they were companies that sort of were together enough to want to run this cloud infrastructure together, then that could be called a community. But it's not a huge, big thing. A quite huge thing is multi-cloud, though. Multi-cloud, I've seen it even confused with hybrid cloud, which it isn't. Hybrid is this, public and private mixed. Multi-cloud is several public cloud providers, so that you don't put all your eggs in the same basket and so on. So this is multi-cloud. If you're still a little bit confused, and your grandmother also is, and you want to explain something as a service to your grandmother, here is pizza as a service. These are things you need in order to consume a nice pizza, all the way from the dining table to the cheese and toppings on top. So if you make a pizza at home, you need to manage all these things. You need to have them, you need to buy them, you need to sort of control all these aspects of pizza making. This is the traditional on-premises way of doing things. This is the couple of months to a couple of years way of deploying a service. You do everything yourself. But if you start outsourcing things, let's start from the bottom, infrastructure as a service, just a few things. I add most of the things myself, but I buy the basics. So what I can do then is I manage the blue thing. So I have my own table and my own soda and my own oven. But the vendor manages and gives me these things. The pizza dough, the tomato sauce, toppings, cheese. These are the pre-made packages you can buy, take and bake, where you just sort of roll out a pizza and you get toppings and cheese, and maybe you can add extra toppings if you want to, but you don't need to. The only thing you need is an oven and somewhere to sit and somewhere to drink. But you can outsource even more. From infrastructure as a service, we can move on to platform as a service. So more pink vendor manages things. So if I order pizza, then I suddenly don't need an oven, because hopefully the pizza is hot when I get it. So I get the pizza and I only need the dining table and something to drink. And of course, there is a final spot over there. It's left conspicuously blank. We have infrastructure as a service, platform as a service, and then of course, software as a service, which just is pay and consume. And the pizza equivalent to pay and consume is going out to a pizza place, dining out. So this is the something as a service in the pizza world. We are soon moving into the world of virtualization. I'm going to talk more concretely about different ways to virtualize our services. But before just finishing this chapter, what is it that made this revolution possible? You know, why does this happen now? There were computers and networks 20 years ago and hard drives. We didn't have a cloud revolution then. Why is it happening now? Is it political? Is it technical? What is it? Is it religious? Well, follow me in a very, very technical and difficult to understand graph. It goes from then to now and from less good to good. I know, bear with me, this is difficult. So things have gone from less good to good in the time span between then and now. So hardware has evolved. Computing hardware has evolved. Remember the time when almost every week, there was this CPU frequency cycle race between Intel and AMD, and they said, this week we have this amount of megahertz, and then the other guy say, well, we have that plus 3, and then the first one says, yes, but now we have what you said plus 2. And they just sort of competed. And that stopped. Did you notice that? That doesn't happen anymore. The CPU clock cycle race stopped. What happened? Well, this here, let me zoom in for you. Let me do this. This is a screenshot from my computer. It shows the CPUs in my computer, the 8 CPUs in my computer. So at some point in time, there were physical limitations for how fast you could run these CPUs. There are, heat limits and width of connection limits. So we started going multi-core, multi-CPU. And at that point, you just add more CPUs. You don't need to sort of increase frequency more and more and more and more and more. We have more CPUs instead. And this was a way to handle the real physical problems that we were hitting with CPUs. But also, it lends itself very good to what was going to come, which is cloud and virtualization, because part of that is modularization, taking big chunks of software that previously were big monolithic things and splitting them up into smaller parts. You will see more and more during this course that is an essential part of virtualization. And the multi-CPU sort of forced software vendors to start thinking about that already there with multi-threading and so on. So you can see here that these 8 CPUs, this is a time scale, of course, with time going from left to right. So in the beginning of this, all these CPUs are idling along except from one, which is, 40% or something like that. And then at a particular moment in time, something happens. I know what happens because I did this screenshot. I hit render on in a piece of Adobe software. We do a lot of video work here at APIS. So I was using a piece of software called After Effects, and I hit render to create a movie, and then all these cores just shoot up to 100%. So the software can really use these CPUs. That wasn't the case when multi-CPUs first entered stage. Then the software pretty much only used one. But now good software can really use all these CPUs. So hardware has become better with multi-CPUs, and software has become better in the terms that it can actually use this multi-CPU world. Networking, virtualization first. Virtualization is something that we're going to talk about in the coming chapters, but since we are at this graph right now, I just need to tell you that virtualization is not one thing that was invented and then has stayed the same. Virtualization has been around for a long time. It was invented, I mean, you can pause now if you want to and guess when virtualization was first made, virtual machines. And when is then for virtualization? And now we're back, if you did pause. Virtualization was pioneered by IBM in the late 60s. So it has been around for quite some time. It didn't look exactly the way it does today, but most of the bits and parts of it were there. So, so virtualization as a concept has been around for a long time. But in later years, there have been features being added in virtualization. We have created the possibility to do live migrations, to move virtual machines from one server to another without it noticing. And we have invented things like containers that we're going to talk about later on as well. So the whole concept of virtualization has evolved. And finally, networking. Since cloud is network access to shared resources, networking is important. You need to be able to transfer large amounts of data in order for this to work for a lot of services. And I don't think anyone will disagree with me when I say that networking capacity has grown a lot over the last decades and is still growing. So essentially, our answer to the question, what made this possible, is technical. It's not political, not religious. Essentially, a number of things have reached the thumbs up level that makes this possible. It's not the case. Sometimes when I ask this, so why are companies doing this, the cloud revolution? And they say, well, of course, because you make more money with cloud. It's more resource efficient. You can use all the servers and network resources and hard drives much better because it scales so well. So it comes down to money. That's their argument. But then again, if I then ask, so didn't these operators want that money 20 years ago, not just like 5, 10 years ago when this started happening? What about 20 years ago? Didn't they want that money? And they did. Our belief is that these graphs were not at the thumbs up level at that point in time. So it's a technical maturity. The next chapter is going to be titled Virtualization. So I will see you there. Bye-bye.